This video is going to be showing you how to work through the example problems and how to use the algebra tiles to help you solve a two-step equation. So we've been working with this equation y equals mx plus b, and we're going to continue kind of working on that equation, but we're going to add another piece besides the constant rate of change and the starting point. So we're going to be reading some word problems, picking out the important information, and using the algebra tiles to help us solve equations. So it says Chris bought a bag of chips for $2 and 4 candy bars. If he spent a total of $10, how much was each candy bar worth? So my question, how much was each candy bar worth? That is what my end goal is going to be today for this video. So I'm going to highlight important information that I do know. Well, I know that Chris bought one bag of chips for $2, so I'm going to highlight that. He also bought 4 candy bars. So I know how many candy bars he bought, I just don't know how much each one was. Now, the other piece of information that is new to us is going to be that total. So he spent a total of $10. And then I'm going to go over here and fill out that information. Well, I know the total kind of sticks out to me, which is going to be 10. Now, he bought one bag of chips. Since I know how much that was, that's going to be my starting point. I know I start off with the $2. And since the 4 candy bars is what I'm trying to look for, my constant rate of change is going to be 4. So when I set up the algebra tiles, my picture is going to have my total of $10. So 3, 6, 9, 10. Notice that I use the positive ones here. Okay. And then the left side of the equal sign is going to show my starting point and my constant rate of change. Now, since I know that he only bought one bag of chips for $2, when I show this next part, I should only have the 2 ones there for the $2. Now, I know he spent the rest of his money on the 4 candy bars. The 4 candy bars is the price that I'm going to figure out. And since I don't know that price, if we don't know something, we always use a variable in its place. In this case, our variable is going to be our 4x's. So when I start here, I'm going to look at my picture. I have 2 positive ones. I have 4 x's, and it's equal to 10 ones. So when I go to write my algebraic side, I know that my equation is going to look exactly like my picture here, where I have 2 plus 4 x's, and it's equal to 10 positive ones. So 2 plus 4x equals 10. So now that I have the algebraic part, I'm going to start using my algebra tiles to help me solve for x. Now, x in this case is representing how much each candy bar is worth. Okay, so let's look. Well, if I have $10, okay, and I know I spent $2 on one bag of chips, what I'm going to do is I'm going to add some negatives here. And these negatives are going to cancel out these 2's. I'm going to add them here. And what I do to one side, I have to also do it to the other side. So I'm going to take these and add it to another set of positives. Now I'm only adding 2 onto the right side because I only added 2 negatives to the left side. So my goal is to get these x's by themselves. So I have to get rid of these positive ones. And I have to do it mathematically. I can't just like move them over. So mathematically, I have to add the opposite of what I see, which is instead of 2 positive ones, I have to add 2 negative ones. So what I do in my picture, I also have to do over here algebraically. So I'm going to say I added 2 negatives here. Oops. Nope. Get that right under the 2. I didn't add the 2 negatives to the 4x's. I only added them to the 2 positives. And again, what I did to one side, I did also to the other. So I also put 2 negatives over here. And then I actually am going to solve that. So what is 2 plus negative 2? Or you can think of it as what is 2 minus 2? Well, 2 minus 2 is 0. So in that case, I can go ahead and get rid of those algebra tiles. Now, over here, it's kind of like saying, well, what is 10 minus 2? Well, 10 minus 2 is 8. Well, since I added a positive and a negative together, that's 0. And I added another positive and a negative together, that's also 0. So I can cancel those out because they make zeros. So I am left with 4x equals 3, 6, 7, 8. So next, all I have left is 4x. And then over here, all I'm left with is 8. So now my new equation becomes 4x equals 8. So notice that every time I'm canceling something out, I should have a new equation to work with. I'm just going to add a line here so that I can make sure that I'm separating everything. Okay. So my new equation is 4x equals 8. Well, if I have $8 left and I bought 4 candy bars, I basically have to separate each candy bar. And then I'm going to separate all of these tiles into equal groups. So if I have a bar here, I have a candy bar here, candy bar there, candy bar here. I'm going to separate by putting the same and equal amount of ones into each candy bar group. So as I separate them, again, I'm trying to separate them into equal groups. So it looks like 1 candy bar is equal to 2 of these yellows, which are $2. And by separating mathematically, separation means to divide. So I'm going to divide, and the number that I divide by is however many groups I just made. Well, if I look here, I made 1, 2, 3, 4. I divided everything equally into 4 groups. So I took those 4x's, divided into 4 groups. I also took those $8 and divided into 4 groups. So that tells me in one group, oops. So that tells me one group of x is equal to 2 ones. So I'm going to write that. 1x, I'm just using the space bar here. So 1x ends up being equal to 2 ones. So that right there tells me how much each candy bar actually is. X equals 2. X, like I said at the beginning, is the number of candy bars. Or sorry, how much each candy bar was worth, because I know I bought 4 of them. So each candy bar is worth $2 according to the equation that I solved. X equals 2, therefore each candy bar was worth $2.